Intermolecular forces are non-covalent interactions between molecules that can be forces of attraction or repulsion. They keep liquids and solids together but don't have much effect on gases. They are much weaker than intramolecular forces, that is, covalent bonds within the molecules. There are 4 different types of intermolecular forces: hydrogen bonds, dipole-dipole, dipole-induced dipole, and instantaneous dipole-induced dipole. The last 3 together are called the van der Waals forces. Let's look at them from strongest to weakest.
A hydrogen bond occurs between a hydrogen atom and an oxygen, nitrogen, or fluorine atom. In these cases, the electronegativity is very different between the hydrogen and the other atom, so the electrons will be pulled very close to the oxygen atom. The positive dipole is attracted to the negative dipole, creating this bond. In water, each molecule can form up to 4 hydrogen bonds thanks to the 2 lone electron pairs. In ice, all molecules form 4 bonds, while in liquid water they form fewer bonds, which makes it weaker. Also, without the strength of the hydrogen bonds, water would exist only as a gas in room temperature, judging from its molar mass. A dipole-dipole bond is formed because of the uneven distribution of charge of polar molecules. The negative and positive dipoles of 2 polar molecules attract each other. This creates a bond similar to the hydrogen bond, but not as strong. In a hydrogen bond, there is a greater difference in electronegativities, so the atoms will be more attracted to each other, giving a stronger bond.
In a dipole-induced dipole bond, a polar molecule forms a bond with a non-polar molecule. The chlorine atom in this polar hydrogen chloride molecule will repel the electrons of one of the chlorine atoms in this dichlorine molecule, creating 2 different dipoles, even though the atoms have the same electronegativity. Unlike the permanent dipole that's formed when the atoms have different electronegativities, this is an induced dipole that only occurs in this type of bond and in London forces. This bond is weaker than the dipole-dipole and hydrogen bonds, since the induced dipole isn't as firm as the permanent dipole. In London dispersion forces, or the instantaneous dipole-induced dipole bond, none of the molecules have permanent dipoles, like when 2 dichloride molecules bond. In this dichloride molecule, all electrons will for a moment spontaneously be closer to one of the chlorine atoms. This creates a dipole, which will create an induced dipole in another dichlorine molecule, like in the dipole-induced dipole bond. This is the weakest bond, and it only ever lasts for a brief moment.
As we've seen, the strength of the different bonds depend on the different polarities of the molecules. These strengths are what determine the boiling points of different mixtures. The stronger bonds, the more energy you have to provide to break the bonds.